Hello dear students, in this video we will be starting a new topic which is EMF or cell potential. EMF stands for electromotive force and it basically is the difference between the two electrodes of a cell. So here it is written that maximum potential difference between two electrodes of a cell. So EMF basically is the potential difference between cathode and anode, which is written in this manner: E cell is equal to E cathode minus E anode. So we know that reduction takes place on the cathode and oxidation takes place on the anode. So it can also be written as E cell is equal to E cathode, which is reduction, minus E anode, which is oxidation. Now there is also one form which we can write, which is the total EMF is equal to E cathode reduction minus E anode reduction. That means reduction potential of anode. So E cell can be written as reduction potential of cathode minus reduction potential of anode. This can also be written in this manner: E reduction potential of cathode minus E reduction potential of anode. Or E cell can also be written as E higher, that means reduction potential of cathode is higher minus reduction potential of anode is lower. Now the question arises here is that at anode oxidation takes place, so why are we writing reduction? Remember one thing: oxidation potential at anode is equal to minus reduction potential at anode. If we want to write reduction of anode, we just have to put a minus sign. So this one, it comes as, this is the, you can see this is the formula: E cell is equal to reduction potential of cathode minus oxidation potential of anode. Now this can also be written in this manner: reduction potential of cathode minus reduction potential of anode, because oxidation potential at anode is the minus of reduction potential at anode. So it can also be written in this reduction format. So you have to remember this, that the oxidation potential at anode is equal to the minus reduction potential at anode. That is why we are writing reduction. Let us see the next topic: standard hydrogen electrode, abbreviated as SHE, She. Now all standard EMF denoted as E0 are calculated with respect to She. She is a hydrogen electrode where hydrogen gas is used. Now this also uses a standard condition which has pressure 1 atmosphere. Hydrogen ion concentration is taken as 1 molar and standard electrode potential of She is always considered as 0. Let us have a look at the electrochemical series given in page 71. Electrochemical series, also known as activity series, describes arrangement of elements in order of their increasing electrode potential values, which means that elements are arranged in order of their increasing electrode potential values. From this electrochemical series, we can see that the reduction potential of She, that means hydrogen electrode, is considered to be 0, just as I have explained earlier. And from this very series, you can see that fluorine has the most positive reduction potential value and lithium has the most negative electrode potential values. Now what does positive and negative value mean? Positive reduction potential value means it will get easily reduced, and negative reduction potential value means that it will not get reduced easily but it will be oxidized. From this electrochemical series, we can know which will get oxidized and which will get reduced. So this series is a very important series. we can see that the reducing agent strength increases from top to bottom, and the strength of oxidizing agent increases from bottom to top. Now let us see some application of electrochemical series. Electrochemical series, we have already discussed that elements are arranged in order of their increasing reduction potential values. Now what are the application of this very electrochemical series? We will see it now. The first application is that it helps in determining the relative strength of oxidizing and reducing agent. But how is it going to help us in knowing the relative strength of oxidizing and reducing agent? Now, those substance which has greater tendency to lose electron, they will act as a strong reducing agent, while those which have greater tendency to gain electron will act as a strong oxidizing agent. That means if a substance loses electron, it will act as a strong reducing agent, and those which gains electron will act as a strong oxidizing agent. Now the next one is that it helps in predicting the feasibility of the reaction. It helps us to know whether a reaction is spontaneous or non-spontaneous. But how is it going to help us in doing so? Now, those species which has higher reduction potential act as a cathode, that means gain electron, while those which has lower reduction potential will act as an anode, that means it will lose electron. That means it says that a given redox reaction or any reaction will be spontaneous or feasible only if the species which has higher reduction potential, it should act as a cathode, and those which has lower reduction potential should act as an anode. So this is the criteria for a reaction to be spontaneous. Now the next one is that it helps in predicting whether a metal can liberate hydrogen from acid or not. So this very electrochemical series will help us in predicting whether a metal can liberate hydrogen from acid or not. But how? This says that only those metals can liberate hydrogen from acid which have negative value of reduction potential. Now if you check out the electrochemical series, those which have negative values of reduction potential, only those will be able to liberate hydrogen from acid. Now calculation of cell potential. We have already discussed about the calculation of cell potential in our previous video. So this electrochemical series also help in calculation of cell potential. Now the cell potential calculation is done in this way. E cell is equal to E cathode minus E anode. But how are we going to calculate this? We need some values. Without values, we will not be able to calculate the cell potential. So this value we are getting from electrochemical series. So electrochemical series, every value mentioned in electrochemical series for a particular reaction is very important in order to predict the relative strength of oxidizing reducing agent, even predicting the feasibility, predicting whether a metal can liberate hydrogen or not, even calculation of cell potential. All these are done with the help of electrochemical series. So we can know that how important is this electrochemical series and the values given in this electrochemical series. Now let us see Nernst equation. Before we proceed further with this equation, if you remember standard electrode potential, let us recapitulate once again. When electrode potential is calculated in standard conditions such as temperature 298 Kelvin, pressure 1 atmosphere, concentration 1 molar. But how will a standard electrode potential be calculated when this standard condition is not present? That is why Nernst equation came into being. Nernst equation is basically used for calculating standard electrode potential when these standard conditions are not present. So let us see for half cell. This half cell is basically indicating reduction. Electron is being taken up and we are getting a pure metal. That means reduction is taking place. So in this non-standard condition, now for this half cell reaction, it does not have a standard condition. Now when this standard condition is not present, how are we going to calculate the standard electrode potential? So we will see how we will calculate it, but it will be done with the help of Nernst equation. Now when non-standard condition is present, EMF in non-standard condition becomes equal to the EMF in standard condition minus gas constant into temperature divided by number of electrons that have participated into Faraday's log concentration of M divided by concentration of M and N plus. Now this very equation can be used to calculate the electrode potential in non-standard condition. That very equation can be written in this format. The previous equation we have written in terms of ln, but now this equation is written in terms of log. I'm sure you know the difference between ln and log. You have studied in your maths. ln means the base is e, log e. Log means the base is 10. Whenever we are using log, we always have this number 2.303. If you remember the previous equation, when we used ln, this number was not there. Now let us see when we use log what will be the changes made. The equation will follow the same, that is EMF in non-standard condition is equal to the EMF in standard condition minus 2.303, it is coming from the log 10. Gas constant into temperature divided by number of electrons that have participated in the half cell reaction into Faraday's log concentration of M when it is solid form. Whenever the reaction includes a solid, the concentration of M will be considered as 1. That is why we have directly written 1 divided by the concentration of Mn plus. So the reaction follows the same. Just when we use log, we are going to use 2.303. We know that gas constant and Faraday's have a fixed value. That is, gas constant value which we will use is 8.314 joules kilo inverse mole inverse. And Faraday's value will be 96500 coulombs. This value are fixed, it is not going to change. Now if the temperature is mentioned as 298 Kelvin, Nernst equation for a cell can be written in this manner. That is, E cell, that is the non-standard form of EMF, is equal to standard form of EMF minus RT divided by NF ln Q. RT and NF you already know by now. ln Q. Q is the reaction coefficient, which can be written as the concentration of the product with their coefficients and concentration of the reactant with their coefficient. the final reaction for the cell can be written as E cell is equal to E naught cell minus RT divided by NF ln. Instead of Q, we can write the simplified form. Now since it is ln, we have no numbers here. But if we are going to write the equation in the form of log, then the equation can be written in this manner. E cell is equal to E naught cell minus 2.303 RT divided by NF log and Q value. The Q already we have calculated in this form, so the final equation can be written in this manner when a non-standard condition is present and the temperature is 298 Kelvin. This E cell can be further written in simplified form, but the condition is that the temperature should be 298 Kelvin, the gas constant value should be taken 8.314 and Faraday's value should be taken 96500. When this condition is fulfilled, then instead of writing 2.303 RT divided by NF, we can directly write 0.059 divided by N. N is the number of electrons taking part in the reaction. So instead of writing this long process, we can directly write down this value, but only if this condition is fulfilled. That means E cell can be simplified in this manner. E naught cell minus 0.059 divided by N log Q. Q value we already know it is this, but we are writing in simplified form. But now let us see what happens at equilibrium. At equilibrium, E cell is considered to be 0. Why 0? Because there is no change in the concentration. That is why E cell is 0 for equilibrium state. Now if E cell is 0, the final equation or the final cell can be written in this manner. E naught cell is equal to 0.059 divided by N log K. How log K is coming? At equilibrium, Q will become equal to the cell constant K. And K is the equilibrium constant. But this applies only at equilibrium. Only at equilibrium, the Q will become equal to the cell constant K. So this is all about Nernst equation.